Hey guys, how are you doing? Today I'm going to show you why the derivative of cosine of x is equal to negative sine of x. So showing that the derivative of cosine of x is negative sine of x, it's pretty easy, okay? And it's pretty cool to do it this way, okay? Well, we don't even need to set up a derivative definition. So we need to find how much this is. And we can do this by rewriting the cosine function into something else, okay? Whatever we want. But we need to find something. And eventually, well, you're going to get to the same point either way. So there is a complementary rule in trigonometry that is going to allow us to do that. And that is basically the complementary rule, okay? This is probably something that you know. This rule basically tells us that if we have cosine of A and we also have sine of B, these two guys are going to be the same only if a plus b is equal to pi over 2, okay? Or just simply 90 degrees. Now, the thing about this is that you can write in terms of x, so instead of having just a and b, so you have like the same input or the same variable notation, you could write it like this. So you would have cosine of x is equal to sine of pi over 2 minus x. The idea is that you can make, if you add the two inputs, they need to be equal to pi over 2 or 90 degrees. And in this case, that's what we're doing, okay? Because you can add x to negative x plus pi over 2 and you're going to get pi over 2 again, okay? Now, this is important because we know how much cosine of x is. And we need to know how much cosine of x is. So we can rewrite this as the derivative of sine of pi over 2 minus x. And now we just need to find this derivative using the chain rule, okay? And how do we do that? Well, let's do it this way. So you don't normally assign variables explicitly. So, like, you don't say, well, I'm going to let the variable u be equal to something, but I'm going to do it in this case so you see it, how it goes. Pi over 2 minus x is going to be equal to u. So in this case, we're going to take the derivative with respect to u for the function sine of u. And this is just going to be a cosine of u times the derivative of u with respect to x, okay? And yeah, that's correct. And now, well, what do we need to do? Well, we need to find the derivative for the function u. So du over dx is just simply going to be equal to, this is a constant, so pi over 2 goes to 0, and negative x, we know the derivative of x is just 1, multiply negative 1, you get negative 1. So we're going to get that, the derivative, I'm going to write it again, the derivative of cosine of x can be written as cosine of u, and we're going to plug in u later on, times negative 1. And this is going to be equal to cosine of, how much is u? Pi over 2 minus x times negative 1, which is just going to give us negative cosine of this complement right there. Now, well, you might be wondering, well, what the hell did we just did? Because we get that cosine of x is equal to this, to negative cosine of this, and this is true, but we need to go back to the complementary rule, okay? Now, what do we want to do? Remember that if you have cosine of pi over 2 minus x, that is also equal to, so cosine of pi over 2 minus x is equal to sine with an input such that the addition of the two inputs is equal to pi over 2. And then it's just simply going to be x. So we can replace this with sine of x. So we get that this is going to be sine of negative sine of x, okay? And this is our answer. Basically, that is what we wanted to show, that the derivative of cosine of x is negative sine of x. And how do you do that? Well, you do it using the complementary rule, okay? Which allows you to represent cosine as another function in terms of sine, and we know how to differentiate sine, okay? And we know the chain rule too, so we can do everything. So, well, I hope you guys enjoyed this video, and see you in the following one.